Alright, maths friends, here's the flip learning on geometric sequences. This is going to be a relatively straightforward one, but it's definitely worth watching. I'm going to just show you a few things. I'll describe what a geometric sequence is, and then show you a few formulas you need to know, and some that are in the formula book. Just go through a quick set of objectives for this session. We're going to understand and be able to work with geometric sequences and series, including a formula for the nth term and the sum of a finite geometric series. A couple of things. Sequence is just the list of numbers. If they've got a plus sign in between them, it's a series, so we're going to add them together. So the sequence is a list, a series is an addition. Learners should know the difference between a convergent and divergent geometric sequence and series. I'll then go into that in detail at the end, and we'll make some notes in our book. And then finally, we're going to understand and be able to work with the sum to infinity of convergent geometric series. So I'll link these two together, including this notation. Now you do know what the modulus means. So this here means that R can be between 1 and -1 and not inclusive. And then we're also going to use the modulus notation. So that's the same as that. A couple of notes. The term geometric progression may be used, so I might use that. Don't think I do. First term I'll use A and R. N terms will be denoted S with a small n, and the sum to infinity is S with a small infinite symbol. So we'll get cracking. So I'm just going to introduce to you what a geometric sequence is. If you realise here, I add 2, but I'm not adding again. You'll probably notice that the sequence is going up by 2, but by a multiple. So I'm multiplying by 2, so clearly the next term here is going to be 32. So this is called a geometric sequence. Arithmetic is addition, so A for arithmetic, A for adding, and a geometric, we'll just have to remember, as being a multiplication sequence. So this is a sequence of numbers. Obviously, as I said before, if I put it in, that's now a geometric series. And obviously the commas would go as well. So you notice now that's a geometric series. What's quite interesting here is the following. This here I'm going to call A as my first term. A bit like we're going to do, or you have done in arithmetic progression. If you've not done arithmetic, it's a sequence, but instead of timesing by 2, we add 2. So anyway, the first term, A, is 2. The next one, we're going to times by 2 each time. That's called our common ratio. So I'm going to say R equals 2. So this term is A. This term is A times R. That's my second term. This one here is A times R twice, so AR squared. This one here is AR cubed, and our fifth term is AR to the 4. If I want my nth term, so I'm going to call a term UN. If I want that term, I'm going to have A and times it by R, but not n times. I'm going to do n minus 1 times. Here's why. A is 1. AR is 2, so that's 1. And I want the second term, so it's 2 minus 1 is 1. Third term is AR squared. Fourth term, AR cubed, so it's 1 less. I'm going to, well, not be a pain, I'm going to be honestly truthful here. You definitely need to know that. That is not given to you in the formula book. So we're going to make some notes in a minute, and then I'll talk to you about some other stuff. So we're going to go and make some notes in our books now. So if you grab your books out, set the title from the first slide, which is just, well, geometric sequences is fine. And we're going to make some notes. So what we got here is a geometric sequence has a common ratio. Now the important bit here is that it's a multiply. It's a multiplicative sequence. So you're timesing each time, not adding. You need to know the difference between them. And as I mentioned previously, the formula for this is that. Now the best way to say what each term is actually don't write UN is the nth term, is just put an arrow and that next to your notes. That's your first term, and R is your common ratio. Just annotate it with these words below. So pause the video now, get those notes in your book, then we're going to show the formulas for series when you add them up. But you need to know this, it is not in the formula book. Used to be, it's not anymore, but let's be honest, it's not too hard. So pause this video and write that down now. So I'm now going to prove this formula. Now this formula is given to you in a formula book, and we'll write it down later. well, we'll probably write it down in a minute. And it's the sum of the first n terms. Now, you might see it written like this, or you might see it written with the r terms swapped. I'll always write it like that, because that's how it's given in a formula book. Once you get your book open, we'll actually make a note of these. And as I said nicely before, this is the second page after the cover of the formula book. It says geometric series, because obviously they're additions. You get the sum to n there, and this sum to infinity that we're going to use later. So, best thing to do, jot them down in your books. And the best thing to write next to it is given in formula book. Sorry, it's in yellow, but it's fine. So pause it, write them down, and I'm actually going to prove this one to you now. And it's worth you seeing it before I prove it. So, yeah, jot that down, and then, well, pause the video, jot that down, and then you can watch me prove it. So this proof's, yeah, it's quite famous, and it's definitely worth knowing it. Could ask you to construct it. It's quite a famous one. It's got a little trick. Now, the worthwhile is I'll go through it actually, and I'll tell you how I remember it, because there's some nice little tricks there. I'm going to write the sequence out again. Now, if you notice, there is n terms here. First term, second term, third term, n minus 1 term, nth term. So there is n terms. That's why I'm summing to n. I'm just going to write the whole sequence out again. So I've got 2. Now, I'm going to change this one by r. And what that's going to do here is change this to an AR squared. Then you're going to get an AR cubed. And then these here are going to be n minus 1. And then n. As you can see there, I'll just times that sequence by r. Now, as you'll see later on, I'm going to subtract them. Now, what's nice about subtracting them, I've got a, I'll just have a. So I've got Sn minus Rsn equals a. This one, take this one, well, there you go. This one cancels with that one when you take them. The next term here will cancel with this term here, and so on. And also this term here will cancel with whatever term lived here, just before this one. You can see that that one cancels as well, and then you'll get minus AR to the n. I'm going to factorise both sides. Here I can pull out an Sn, and you'll get 1 minus R. Here I can pull out an A, to get 1 minus Rn. And nicely done, I can divide this side here by 1 minus R. So that there is a formula that was given in the formula book. Now you might be like, wow, well, you're just really good at maths, Rob. And the fact is, I had to pause this video and look at the proof. Not look at the proof, make sure I could do the proof again, so it was quite slick. The best way forward is I want that at the bottom. So I know here I've got Sn, and I need to take away R lots of Sn. So you can see that by timesing up and working backwards, that I needed to take off R lots of Sn. So it's a bit of a sly one. That is the formula, and all we're going to do now is we're going to use those 2 formulas that we derived so far in this first example in your books. So, jot this in your books. Pause it so you can write it down and you don't hear me over the top. Jot this in your books, so write it all out. You can leave gaps or whatever and do it as we go. And we're going to work through this one together. So, pause this, jot that down. Okay, I'm going to start nice and straightforward. This is 10 and 11, and they're the first 2 terms. So the first term of a geometric progression, said I might use that term, is A. The second one, if you remember, is AR. So I know instantly that A equals 10 and AR equals 11. Now there's a few ways of getting what R is. You know A is 10. So 10 lots of R equals 11. So R equals 11 over 10, or 1.1. 11 over 10 is probably better. And we've just got our first answer. The common ratio is 1.1 or 11 over 10. So we pause this. If you want, write that down now. So I'll just jot them at the top because I'm going to use them to find a 17th term. Now, hopefully you're like, well, use 17 to the 17th term is AR to the 16. It's 1 less. It's n minus 1. You could write the formula down first, but you should be getting to a stage where you're like, well, it's 1 less, because I'm going to times by the ratio 1 less time. All I'm going to do now is stick in the numbers, so that's 10. I would be careful here. You need a bracket if it's 11 over 10. You don't want to raise the 10 to the power of 16. So you jot that down, and we should get the answer as follows, which is 45.9 to 3 significant figures. So that's your answer for the 17th term. Put 3SF if you want. Okay, don't need the answer for that one for the next bit. So pause that, jot that down, have a go yourself, make sure you're happy with why it's 16 and not 17, why you need the brackets, type it in without if you want, realise the answer's probably wrong. If not, you've probably just mastered a calculator skill. Next point now is going to find us some of the first 20 terms. Now I would use your formula book for this, because you get S20, and that's going to be A1 minus R to the 20 over 1 minus R. 20 because it's N in the formula book. It wasn't N, take 1, and the proof in the last part of this video should have convinced you why it's N and not N minus 1. Anyway, sub the numbers in. Again, I'd be careful here. May as well do it with you. You get that 1 minus 1.1 to 20. Make sure you're just doing the 1.1 or the 11 over 10. And 1 minus 1.1. Probably type it all in your calculator together, and you should get the answer that follows. And in true Blue Peter style, you should get the answer to something else. I told you it was true Blue Peter style, where they always mess up. That's one for later. Then you get 1.1, 45.9, and you should get 473 to 3 significant figures. So you can see how I've answered that. Make sure you got that written in your notes. Pause it here if you want. I'm going to give you a question to have a go at, though. Nice and straightforward. Have a go at this one. Find the common ratio in the first term of the geometric progression, where the second term is that, and the fifth term is this. What you need to do is you need to find the general form of the second term, the general one for the fifth term, and then do some algebra with him. And I'll go through it if you need to. So pause it, have a go first. Yeah, see if you can do it, and I'm going to go through it. So pause now. Okay, hopefully you've had a good go with it. What you should notice is the fifth term is indeed that. Now the best way of solving this equation is you could rearrange for A and sub it in. So one way is A equals 4 over R, sub that in. So you get 4 over R times R to the 4 equals 1 over 8. That gives you R cubed, so you get 4R cubed equals 108. You can then just divide 108 by 4 and get 27, and then cube root both sides and you get 3. Sub in 3 here, and you get 3A, or A times 3 equals 4, so A is 4 over 3. So there are your two answers. Another way of doing it is as follows, and I don't know why I enjoy this way better, there's no right answer, is I like just dividing them. It's the same idea as what before. I think it's just one less line, but seriously, just rearrange that, sub it in. Divided, it's always quite nice because the A's cancel and you get your R cubed here. So that's quite nice. Hopefully you managed to get that. If not, have a go at it again. Doesn't matter if you've seen the answers. Every day's a learning day and all that. Here's the questions for you to have a go at. I'm going to do another example later. But we need to make sure we're happy with this. So on some paper, and not in your books, because you don't want this in your books, there's just 5 questions there to have a go at. Go. Pause this video, have a go at them, and I'll show you the answers in a bit. But yeah, definitely have a go at them first, because we won't cover this in class. And there you go. They're the answers. So have a quick mark at them. Pause it. Just make sure you got... Here you could have a negative common ratio. And what that's going to look like from the sequence before is this. This is a geometric progression, but instead of timesing by 2 each time, I'm multiplying by minus 2. So that's how a negative ratio works. You'll notice it just, what's it going to do is it's actually going to do something called oscillating. So if I plotted the points and joined them up, so that's term 1 is 2, then this one's minus 4, then it goes to 8, goes to minus 16, obviously it's going to get more and more sporadic up here, and it makes an oscillating pattern. What that is actually called is that sequence is never going to go towards the number. It's going to diverge. And that's going to bring me to my next point. And that is when we have a sequence that indeed converges. So the sum to infinity. If the ratio is between 1 and minus 1, and you might have seen the notation before, that is indeed the same as writing that. The sum of the terms of the geometric sequence with the first term a and ratio r tends to this limit here. Now that we wrote down before, and we did actually write that next straight from the formula book. That says the number of terms tends towards infinity. If this is the case, if this is true, if r is between -1 and 1, or the modulus of it, the absolute value is less than 1, the sequence is said to converge. If the ratio is bigger than 1 or less than -1, or the modulus is bigger than 1, then this will never have a value. Because what happens is you just go towards infinity, and infinity is not a number, so it won't have a value. The series is then said to diverge. This is what we mentioned in the learn objectives before to know what converge and diverge means. Converge goes towards a limit, diverge doesn't. So pause that there, write that down, and I'll just quickly show you where this comes from. So what's going to happen here is, if I've got this sequence here, if n goes really, really big, then this, I'm going to be taking away just a really big number if r is a big number. However, if r is a fraction, for example, let's say r is 0.1, if I do it so many times to the power of n, an infinite amount of times, then r is going to go towards 0. Because it's going to be like 0.00, oh, not that many points, 0, 0, 0, and so on, an infinite many times, which is just going to be ultimately, 0. So that'll end up going towards 0. 1 take 0 is 0. And you'll, oh look, surprise, surprise, you get that. So that's why it works. Because type that in your calculator, 0.1 to any power of like 99, it's just going to spit out 0. Similarly though, if I did r equals a number outside this range here, 2, well 2 to any big number, which is going to be massive. So I'm then going to do 1 minus a big number, which is a really small number, and then it'll cancel with, then it'll still just give me a ridiculous answer. And it will just depend on all sorts of stuff. So converge if this is true. Well, not that's true, that r is in those values. It doesn't have to necessarily be 0.1. So, final notes for your book. Pause this here, fast example, and there's 2 questions for you to have a go at. And then we'll have a little summary. So pause this video here, copy the examples down, and I'm going to go through them with you. So, going through the first one. The first term of geometric sequence is 8, so I know a is 8. The sum to infinity is 10. Sorry. That sum to infinity is 10. Can't get my numbers right. Sum to infinity equals 10. Find the common ratio. Well, you know that the sum to infinity is a over 1 minus r. The sum to infinity is 10. A is 8. And 1 minus r is just 1 minus r. Times up by 1 minus r. So this is my next. You go down on your page, you get 10 times 1 minus r equals 8. Expand your bracket or divide by 10. It's up to you. I'll divide by 10 because that's easy. Then I'm going to add r to this side and then take off 0.8. Now what's quite good there is r is less than 1 and bigger than -1. So this actually works. If I got r equals 1.2, there's not going to be a sum to infinity from what I said before about r. So this is spot on, that's the right answer. So, yeah, have a go at A. You might want to just look away from this video, see if you can do it yourself now, and then I'll do B. So for B, geometric progression has that as its second term. So AR is the second term, and that's equal to -1.2. The sum to infinity is 5. Find the common ratio. So we get a little bit harder here. Now I still know that the sum of infinity is a over 1 minus r. I know that is 5. I don't know what a is. I do know in fact that a though equals minus 1.2 divided by r. And I get that as follows. I'm now going to times both sides. So we're going to solve this equation. Hopefully I've not mentioned it already. I have to quickly pause what's going on. I'm going to times up by that. So the 1 minus r. So again, I'd carry on under yours. It's always a bit of a pain when I've run out of room. So you get 5 lots of 1 minus r equals minus 1.2 over r. So I'd expand that bracket out. So you get 5 minus 5r equals minus 1.2 over r. Now you're in a bit of a dilemma. Oh, you should be keen now to times up by r. and then you've got yourself a quadratic. So I'm going to just put this on this side here and rewrite it. Well, I'll move everything to the right, it's a bit easier. So you get 5r squared minus 5r minus 1.2 equals 0. Best bet, stick it in your calculator. And you should get the following two answers. You should get r as 1.2 or 6 over 5, and then you get r as minus 0.5 or 1 over 0.2, sorry. So that's 6 over 5 and minus 1 over 5. Now you should be like, hang on, Rob, you said find its common ratio, not the possible values of r, or more than 1. Well, that's wrong. Because, I'll pause and hopefully you thought, that is in this range here. That's bigger than 1. So r here for this one, bit of a pain when I come to it all off, is minus a fifth or minus 0.2. So, yeah, definitely have a go at that. Try and write it out better than I have. Go down your page. I've obviously run out of space. And then there's a couple of questions for you to practice. Cool. Yeah, so have I got the questions here? There's just 2 questions to have a go at. Then I'll stick the answers up. Just some algebra in it. So, yeah. Yeah, see if you can have a go at the arithmetic one to start off with. If you've done that in class, then great. If not, if you've not done this arithmetic one, then obviously just skip part A. You can still do the second bit. So this bit here is obviously optional. If you've done the arithmetic, do it. It's definitely worthwhile. So yeah, pause the video, have a go at them. Again, miss the first part. Don't miss the whole question if you've not done that. So here are the answers. So yeah, you can have a quick check of what you've got. There's one answer. You have to show that. Try some answers here for the first one. You can always type in your calculator and check and show this working out to show you got it all. And you should get those two as the answer there. You do get a repeated root. So watch out there when you factorise it. You should get this here. And then similarly for this one, you get these as the answers. So, great. Hopefully you found that useful. What you should know now is what a geometric series and sequence is, how to get the nth term, the formulas for the summations, n and infinity, but they're in the formula book, the proof of the sum formula, and also what convergent and divergent means. So, hopefully you've hit all them. Great. See you later.